So in this lesson, we are going to talk about geometric proofs. So a lot of the stuff we're going to see, we're going to be using our hot pink sheet, those reasons, and as well as our symmetric, reflexive, and transitive. So the symmetric, reflexive, and transitive can all be used not only with an equal sign, but also with a congruence symbol. So reflexive property of congruence, symmetric property of congruence, and transitive property of congruence. So no other new reasons. We're going to be using our reasons that we've seen in the past. So remember, our first reason is always given, usually. The next, it says segment addition postulate. So which one actually could we add segments? It looks like this segment here has two parts and then a whole. So we're going to take and add an AB plus a BC. The left plus the right equals the total AC. Now it looks like from here to here. Now, if you didn't know what to do, you could also look at where they're going to and kind of work backwards. That is also a good strategy. So how do we go from a BC to a DE? Well, we know they're equal up here. So they replaced. What's it called when we replace something? It is substitution. And then again, don't abbreviate with sub, because that might be subtraction that we're thinking if we see sub. All right, so next, I want you to go ahead and fill in as much as you can what goes here for number 1 for the reason. Given, we have another given, so it looks like they're splitting these up into two different statements. And then what goes last, right here. We know what goes last. Now, this is never ever proved. The reason is never proved for the last reason. We need to know where we're coming from 3 to 4, and then we put the reason. So prove, again, is not a reason, it's just what we're trying to get to or ultimately trying to prove. So fill in as much as you can, and then we will continue to fill the rest in for you to check. Nothing at all, you could at least fill in 3 things out of the 6 that are missing. So that's half of the things just from knowing that our first one's given, this one was given, and then what we know has to go last. So now it says midpoint. What do you think we're going to put next? Well, probably the definition of midpoint. Anytime they give you the word, you're going to define it. So what does it mean for it to be the midpoint or midpoint theorem? Because we'll most likely do congruence. So definition midpoint or midpoint theorem's actually probably a better choice, but midpoint theorem, because we want to go congruence. Since these are all congruent, we want to go congruent up here. We don't want to go equals and then to a congruence. We want everything to kind of stay consistently the same. So midpoint B is in the middle, so we know that AB and BC are congruent to each other. Now we are saying, I'm going to use some highlighting here, that BC is congruent to EF. So we're putting these two congruent when we know they're congruent to the same thing. So that would be the transitive property. Now, a lot of times we can say the substitution property, but on this one, because it's congruence, you cannot use substitution with congruence, only with equal signs. So this one has to be transitive. There is no other option. You cannot use substitution. And I put POC on this one because it's not property of equality anymore, it's property of congruence. So if you left that off, I would still count that correct, but not substitution. All right, so for our last one here, I want you to again go ahead and fill in what we know, what has to go first, what has to go last, what's our reason, and then we will continue to fill out the rest, or you can try this one on your own. So here's what you should have filled out. Again, 3 things already filled out of 6 missing things, just from what they are giving us. So we put both things in the given here, because this one's not given and this one isn't a given up here. So we know they both have to be on that first step. So sometimes they're separated, but most of the time they're kind of there at the beginning together. So it looks like they're going from a congruence to an equal sign for this step 1 to step 2. So we know that that's definition of congruence. You can be specific and say definition of congruent segments if you want to, but again, if you were to put angles, you would be incorrect. But definition of congruence is fine just by itself. Next is substitution. It wants us to substitute something in. Well, what have we not used yet? We haven't used this yet. So we want to substitute something in here. Well, let's look to see where we're going to. 2 ABs. Well, we have one AB here. So is there a way to change the CD into an AB? Yes, there is. Look at that. CD is AB. So I can go ahead and put AB plus AB is equal to EF. So the only thing I changed was the CD here into an AB, and that was substitution. So now all I'm doing is taking AB plus AB and putting that as 2AB, which is equivalent to that. So I'm not adding, I mean I am adding, but it's not the addition property because it's not happening on both sides. It is just going to be either simplify or combine like terms. And there we go. So the more you practice, at least put what you know and where the givens go and where you're trying to get to, and then kind of use, working backwards or process of elimination one step at a time. And most of the time you can get the rest of your stuff filled in.